It's actually kind of wild to think about, but you will probably spend up to 15 years of your life just staring at a piece of eliminated glass. Like, not working, not talking to your family, not building anything tangible, just staring at a screen.
Yeah, and touching it, an average of 2,600 times a day, which is, that isn't some anomaly. That is literally the baseline data for the average modern human right now.
Right, exactly. We're carrying around this device that acts as like a portal to an infinite compendium of human knowledge, and yet the primary result is that we are chronically exhausted. We're completely scattered, and we're just constantly battling this low-level hum of anxiety.
Oh, absolutely. It's a constant state of overwhelm.
So welcome to the deep dive. We are basically looking at a cognitive landscape that resembles a war zone today. Our mission for this session is to decode exactly why our modern environments feel like they are actively engineered to destroy our focus.
And importantly, we aren't just here to diagnose the problem, right? We're going to get into the hard science of how you can actually reclaim your brain.
Yeah, because we're bringing two very distinct lenses to this. My obsession is the neurobiology behind why we fail to focus. I am fascinated by the brain chemistry, the evolutionary mismatch, and the actual physical mechanisms firing in your nervous system when a distraction hits.
And I spend my life analyzing the productivity side of things. Systems, workflow, environmental design, cognitive capacity. I want to know why a smart, highly capable person sits down to write like a really critical proposal and ends up 2 hours later deep in a video feed of someone power washing a driveway.
I have absolutely been that person.
We all have, because we're fighting a biological standoff. We are going to examine the brutal war happening in your head right now between your ancient animal brain and your highly evolved frontal cortex.
Which is really the foundation we need before we build our toolkit. Because once you understand the biology, we can arm you with the actionable protocols. We're going to dissect the exact mechanics of hyperfocus for deep work.
Yeah, and we'll look at a precise mechanical breathing tool called the physiological sigh that uses your lung architecture to just instantly halt your stress response. Plus, we'll unpack the wild protocol, which uses specific natural environments to physically restore your brain's capacity to pay attention.
But let's lay down a ground rule for you, the listener, before we even start. This deep dive is absolutely not about finding ways for you to work more hours.
Right, no. The whole hustle culture paradigm of grinding for 14 hours a day is just biologically bankrupt.
It really is. The objective here is intense efficiency and profound restoration. We want you to work so well that you can actually log off, disconnect, and enjoy your life without that phantom phone vibration feeling or the guilt of a totally scattered day.
And that guilt is real. It's like the cognitive tax we pay for fighting our own biology. So I think we should start right there. To understand why it feels physically painful to stare at a complex spreadsheet or, study for an exam, we have to look at the timelines our brains were actually designed for.
Exactly. The core conflict here is entirely evolutionary. For 99% of human history, the concept of a 5-year plan or doing your quarterly tax returns, that just did not exist.
No, of course not.
The environment our neurology evolved in was an immediate return environment. Survival literally meant securing an immediate dopamine hit. You found food, you ate it, you spotted a predator, you sprinted away. Your brain is this extraordinarily efficient machine that is hardwired for survival in the present moment.
Right, because in a hunter-gatherer context, if you spent your afternoon sitting totally still, contemplating some hypothetical scenario 5 years in the future, instead of, foraging for berries or scanning the horizon for tigers, your genes were abruptly removed from the gene pool.
Yeah, nature did not reward the philosophers back then.
Exactly. Doing the thing that kept you alive and happy right now made you a highly successful organism. So, the brain's logic developed this very simple, primitive heuristic. If an action triggers a big release of dopamine, it must be intrinsically good for your immediate survival.
And then, we fast forward to today, and we have this newer, shiny piece of hardware right behind our foreheads, the prefrontal cortex.
A responsible adult in the room.
Exactly, the responsible adult. The prefrontal cortex manages the college applications, the retirement portfolios, the gym routines. It is entirely responsible for delayed gratification. But it requires an immense, metabolically exhausting amount of willpower to override the ancient animal brain's screaming desire for a quick, immediate reward.
We're effectively asking ancient hardware to run highly unnatural modern software. Early humans didn't need to force themselves to exercise. Staying alive was the exercise. Abstract concepts like books and degrees and career trajectories are entirely modern inventions.
Yeah, the need for sustained, long-term focus without an immediate reward is a completely man-made requirement.
It is. And what makes this so insidious is that our modern world isn't just a neutral environment where we occasionally struggle to focus. It is an engineered minefield. It's actively weaponizing our biology against us.
Yeah, let's really dig into the psychiatric sources we reviewed on this. We mentioned the screen time earlier, the 2,600 touches a day. The real question is, why are we doing it?
Well, it comes down to AI algorithms trained specifically to exploit that exact dopamine system we were just talking about. The engineers behind social media, mobile gaming, the endless news feeds, they aren't guessing.
No, they know exactly what they're doing.
They do. They utilize variable reward schedules, which is the exact same psychological mechanism used in slot machines in a casino. You swipe down to refresh your feed, and you literally don't know what you're going to get.
Right, it's that anticipation.
Exactly. It might be nothing, it might be a boring ad, or it might be a highly stimulating piece of outrage or comedy. And that anticipation, the not knowing, is what massively spikes the dopamine.
And they pair that variable reward with what the psychiatric literature calls pseudo-social rewards. This is such a fascinating mechanism to me, because in our ancestral environment, social connection was literally a matter of life or death.
Right, if you're kicked out of the tribe, you're dead.
Exactly. If you were ostracized, you lost access to shared food and protection. You died. So the brain aggressively rewards social validation with dopamine. It's a survival imperative.
But the brain hasn't evolved fast enough to differentiate between a physical human smiling at you and a digital pixel lighting up on your phone to indicate a like or a comment.
It really hasn't. The neurochemical cascade is identical. Your brain registers a retweet as survival-level social validation. It literally keeps us trapped in an endless loop, constantly checking to ensure our so-called tribe still accepts us.
And even the negative interactions do this, right? The outrage farming, the heated arguments in comment sections, those stimulate the exact same sympathetic nervous system pathways.
Yeah, it elevates your heart rate, it releases adrenaline and dopamine, and it just constantly reinforces the behavioral loop. This is exactly why the sources draw a really hard distinction between high dopamine activities, or HDAs, and low dopamine activities, LDAs.
Right. So HDAs are your fast-paced video edits, your infinite scrolls, your notifications, gaming, and even highly processed foods. They just flood the synaptic cleft with dopamine with zero corresponding effort. You didn't have to hunt an animal or build a shelter. You literally just moved your thumb.
And here is where the neurobiology gets truly dark. Because the brain is obsessed with homeostasis, it always wants to return to a balanced baseline. So when you constantly flood your brain with massive spikes of dopamine from these HDAs, the brain defends itself.
It has to, or it would short circuit.
Exactly. It literally downregulates the number of active postsynaptic dopamine receptors. It says, whoa, okay, this is way too much stimulation. I'm gonna turn down the sensitivity.
Which leads to a baseline shift.
Yes, your baseline requirement for stimulation shifts upward. Because you have fewer active receptors, you build a tolerance. And the psychiatric sources are highly definitive on the fallout from this. Chronic downregulation of dopamine receptors leads directly to increased anxiety, anhedonia, insomnia, and just the complete inability to focus on anything that doesn't provide a massive neurochemical hit.
And think about the implications of a fried dopamine receptor for your typical workday. I mean, if your brain has shifted its baseline to expect a massive spike of dopamine every single time you swipe your screen, how on earth are you going to sit down and do a low dopamine activity?
Yeah, not. It's going to feel like torture.
Exactly. Because LDAs, like reading a dense report, writing code, or sitting quietly to brainstorm, they require patience. They are the gateway to a flow state, sure, but they offer very little immediate reward.
To use a mechanical metaphor, we often compare the brain to a computer, right? Think of your attention like your computer's RAM, its short-term processing power. The prefrontal cortex is the responsible adult trying to run a heavy application, like writing a strategic brief.
But your animal brain is essentially a toddler who just opened 50 background applications.
Right. Social media tabs, news alerts, email notifications, all of these are quietly eating your processing power. Your internal cooling fan is just screaming. You switch back to your word processor, but the whole system is lagging because the background noise is consuming all the resources.
And the only way to cool the system down is to force quit those background applications. You have to temporarily eliminate the heavy, cheap dopamine hits. Which brings us to the concept of a dopamine detox.
Yeah, tell us about that.
Well, if you notice that you can no longer sit through a movie without checking your phone, or you can't read 10 pages of a book without your mind completely wandering, your receptors are down-regulated. You literally need a fast.
You have to starve the system of HDAs to force the receptors to upregulate and become sensitive again, right?
Exactly. Now, the goal isn't to become a monk forever. A dopamine detox is a strategic short-term intervention. It usually means taking 2 to 4 weeks where you strictly eliminate algorithmic feeds, short-form video, infinite scroll environments. You intentionally introduce digital friction into your life.
But there's a crucial second half to that, isn't there?
Yes, and it's the part most people completely miss. The intentional reintegration of low dopamine activities. You cannot just sit in an empty room and stare at the wall for a month. You have to actively teach your brain how to find reward in slower, deeper processes again, like reading or building something with your hands.
Okay, so we understand that our environment is actively down-regulating our neurochemistry. But let's look at what happens when we actually try to sit down and work. I mean, even if I put my phone in another room, I still struggle to stare at the screen and process the data. What is mechanically broken in our focus there?
This is where we have to dive into the anatomy of how we actually pay attention, and specifically this concept of attention residue. Because if you want to master focus, you have to understand the hard biological limits of your attentional space.
Attentional space. Break that down for us.
Think of your attentional space as the active workspace of your conscious mind. It holds whatever you are currently actively aware of. So the words I am saying right now, the temperature of the room you're sitting in, maybe a lingering thought about what you're having for dinner, it is your entire conscious reality in any given second.
And the bottleneck here is incredibly severe, isn't it? The research indicates that human attentional space can only actively process about 40 bits of information at any one time.
40 bits, yes. And to put that in perspective for you, a standard internet connection processes millions of bits per second. Your highly evolved conscious mind is working with 40.
That is humbling.
It really is. So when you sit down to execute a complex cognitive task, analyzing a data set, writing a nuanced email, synthesizing research, that single task demands almost all 40 of those bits. It has to fill your entire mental workspace.
Which completely obliterates the concept of multitasking.
Oh, completely. I cannot emphasize this enough to anyone listening. Parallel processing of complex tasks is a biological fiction. You do not have the attentional space for it.
But people always argue, wait, I fold laundry while listening to an audiobook.
Right, and yes, you can multitask habits. Because habits are governed by the basal ganglia, they run on autopilot and require almost zero attentional space. But you cannot write a critical proposal while actively listening to a colleague pitch a new idea on a Zoom call.
You aren't multitasking at all, you are task switching.
Precisely. You are rapidly, violently yanking your 40 bits of focus back and forth between two entirely distinct cognitive environments.
And the data on how often we do this task switching is just staggering. The research shows that when working on a computer, the average knowledge worker sustains focus on a single application for only 40 seconds before being interrupted. Or, actually more likely, interrupting themselves.
40 seconds. We're literally trying to build careers and synthesize complex ideas in 40-second increments. And this circles right back to the novelty bias and the dopamine system we just talked about.
Yeah, why do we interrupt ourselves every 40 seconds?
Because the prefrontal cortex favors the path of least resistance. Wrestling with a complex problem is metabolically expensive. It's hard work. But opening a new tab to check your email, that requires almost zero effort, and it provides a tiny micro hit of dopamine from the novelty of a new input. We constantly confuse the feeling of being busy with actual productivity.
I want to look really closely at what actually happens in the brain during those task switches. Let's say I'm writing a script. I hit a really difficult paragraph, so I switch over to check my Slack messages for 30 seconds, just to clear the little red notification icon, and then I go right back to my script. It feels instantaneous. But what is the hidden cognitive cost there?
The cost is massive, and it's captured brilliantly in the research of organizational behavior professor Sophie Leroy. She introduced the concept of attention residue.
Let's deep dive into her actual study, because it wasn't just like a subjective survey where people said they felt distracted. She actually brought people into a lab to physically measure their cognitive capacity.
Right, she designed this truly fascinating experiment. She gave participants a primary task. Let's say it was a really complex word puzzle. Then she interrupted them right before they could finish and forced them to switch to a completely different secondary task, like reviewing resumes for a hypothetical hiring decision. And while they were actively working on those resumes, she administered a lexical decision task. Basically, she flashed strings of letters on a screen and asked them to identify if it was a real word or just gibberish as fast as possible.
And the trick here was that some of those words were actually related to the original unfinished word puzzle, right?
Exactly. And she found that participants reacted significantly faster to the words related to the interrupted task.
Which proves what, exactly?
It proves that their brains were still actively processing the first task, even while they were supposedly fully focused on the second task. When you switch your focus from task A to task B, it's not a clean break. A significant portion of your 40 bits of attentional space remains completely anchored to task A.
Oh, wow. So your brain is literally stuck in the past.
Yes. Your brain continues to ruminate, evaluate, and problem-solve the previous task in the background. That lingering cognitive load is attention residue.
So, if I pause my script writing to read a mildly stressful email from my boss, even when I physically look back at the script, a chunk of my processing power is still stuck in the inbox, analyzing the tone of my boss's email. I am trying to write a script with maybe 25 available bits of attention instead of 40.
And the recovery time is what absolutely kills your productivity. The data indicates it takes an average of 22 to 29 minutes to fully clear that residue and return to your previous depth of focus after just one interruption.
29 minutes.
Yeah. So if you were checking your inbox every 15 minutes, you are existing in a permanent state of attention residue. You are literally never actually reaching deep focus. Continually switching tasks makes everything take roughly 50% longer, and your error rate just skyrockets.
I want you, the listener, to just do a quick audit right now. Visualize your physical and your digital workspace. How many open loops are demanding your attention this very second? Look at your browser. Do you have 15 tabs open, shrinking until you can only see the tiny little icons?
Is your email client visible in the background?
Right. Is your phone sitting face up on your desk? Because every single one of those open loops is a visual cue that leaves a smear of attention residue on your brain. They are actively consuming your cognitive RAM just by existing in your peripheral vision.
It's really no wonder people always say they do their best thinking in the shower or, on a long flight without Wi-Fi. Those are environments completely devoid of attention residue. There are no visual cues reminding them of uncompleted tasks.
So, if our attentional space is really that fragile and task switching functionally lobotomizes our productivity, how do we actually leverage our biology to get things done? How do we build a protocol for deep work?
Well, we have to move from a state of fragmented attention to a state of unified attention. And the protocol for this is called hyperfocus. I want to be very precise about this term, though. The source material emphasizes that hyperfocus is not some mystical flow state reserved for, tortured geniuses. It is a deliberate mechanical deployment of your attention.
It is the act of intentionally expanding one single complex task until it completely fills your 40 bits of attentional space. You leave absolutely no room for residue.
Exactly. And the most counterintuitive part of the hyperfocus protocol is that it actually feels vastly less exhausting than a normal distracted workday.
From a neurobiological standpoint, that actually makes perfect sense. Because as we mentioned, regulating your behavior is incredibly metabolically expensive. Every time you feel the urge to check your phone and you use your willpower to stop yourself and look back at the screen, your prefrontal cortex burns glucose.
You're fighting a constant internal battle.
Right. When you eliminate the options for distraction and fully commit the entire attentional space to one object, the internal friction just disappears. You stop burning precious energy on self-regulation.
The protocol outlines 4 specific sequential stages to achieve this state. Stage 1. Choose a meaningful object of attention. Intention must precede attention. You have to explicitly define the parameter. For the next hour, I am only